Thank you so much for joining us today. It's great to have you here. My name is Dr. Natalie Urie, and I'm the lead veterinarian here at Barnwell Bio. I'll be hosting our conversation today. So, the title of today's webinar is From the Field, Real-World Applications of Targeted Investigations Using Metagenomics. So, the goal of today's session is to help everyone understand how metagenomics can be applied practically in the field to support animal health staff and veterinarians. Today, we're joined with two additional veterinarians who I've had a great time collaborating with over the last 6 months on a variety of different projects here at Barnwell Bio. That's Dr. Grayson Walker from Vital Farms and Dr. Jason Sousa with Amic Farms. They both bring really great real case experiences that they're going to share their perspectives on today. So thank you both for joining me. Before I hand it over to the stars of the show, however, I'll start by presenting a case from our collaborators at Midstate Specialty Eggs, who were happy to have us share their data. Before we get into that, though, a few quick housekeeping. Please put all of your questions in the Q&A, and we'll work to answer those at the end of the webinar. And then we are recording, so we'll send it out to all participants right afterwards. And with that, let's get started. So before we jump into the cases, I wanted to give a brief overview on how Barnwell Bio works for those of you that may not be as familiar. So Barnwell Bio's co-founders came from a company that did metagenomic sequencing on human wastewater during the COVID pandemic. From that experience, they believed the same principles could and should be applied to support animal health. With that in mind, Barnwell Bio currently does metagenomic sequencing of DNA on poultry operations. The sampling is really a quick and easy process. We use boot sock swabs to collect litter samples that is an aggregate representation of the birds in the barn. These samples then get shipped to our collaborating lab where they run deep metagenomic sequencing, and then we perform the bioinformatic analysis. This allows us to understand and quantify the complex microbial community, and this includes bacteria, DNA viruses, fungi, worms, protozoa, and anything that really exists on the birds themselves and throughout their environment that leaves a DNA footprint. Results are then uploaded onto our dashboard that tracks microbes over time and across barns for each customer. We also do periodic deep dive reports to review other DNA targets of interest and to look at the microbiome as a whole. Our turnaround time is relatively fast. Results are typically displayed in the customer dashboard about 1 week from shipping samples. So in general, if you sample on Monday and you get it shipped off on that same Monday, that following Monday, your data will be on the dashboard. So with that, there's a few different ways that Barnwell Bio currently works with customers. A few of them include proactive surveillance, and then we do intervention and product assessments. However, today we're going to discuss how we work with customers to complete more targeted investigations. So targeted investigations tend to be a bit more narrow in scope, and they tend to address specific questions. Sometimes they are time sensitive. So to support that, we send customers sampling kits ahead of time. So when an issue comes up, they have the samples, the kits there ready to collect samples, and they can ship them right away. In general, the way this works is very similar to what I've just described. For example, you notice an issue or you have a new product that you've decided you want to test in your barn. You or someone on the operation collects a swab from the barn. Ideally, you give us a call first and we discuss the best sampling plan just so we're on the same page. And then we normally recommend collecting a couple of samples, and you'll see this in our examples that we're going to provide today. So for example, a sick barn and a healthy barn, or a pre and product post-application would be a few examples. So then you send the samples off and it's tested by our lab and runs through our data pipeline. We then review the data and upload it on your dashboard in about that week timeline. One very useful feature that we have on our dashboard is something that I'm going to introduce called alert levels for pathogens. So since we have one of the biggest poultry metagenomic data sets, we're able to compare the relative abundance of specific pathogens to the baseline of that pathogen that we see across all turkey and chicken operations. So this allows us to quickly flag a pathogen that is above the baseline as a medium or high alert level. A medium alert is normally 2 standard deviations higher than what we would expect, and a high alert is 3 standard deviations higher than the baseline. So we're able to use this to really quickly understand your data and understand what should be of concern. You can also send us samples from other species. We've done a little bit of work in ducks and we're just piloting swine. However, And we've collected samples from other locations, such as equipment located in the barn, but we can't provide those alert levels for those samples. So, however, regardless of the species or the sampling location, you'll still receive consultation from our team, myself as the veterinarian, and then we have a great group of data scientists and microbiome experts that can really help answer those questions and figure out the what's next for your specific case. And then what you see on the right here is a few examples of when we would recommend using targeted investigations. So this includes events with overlapping clinical signs. Potentially you have some unexplained mortality. You need help pinpointing a specific disease introduction, or you want to do one of those product evaluations. And we're always open to helping with study design. If there's a specific thing that doesn't necessarily fit into one of these boxes that you want to look into, feel free to reach out and we'll help come up with a plan. And with that quick overview, I want to walk you through our first case, which is actually a targeted investigation around a product evaluation. So recently, we worked with the animal health team at Mid-States Specialty Eggs to evaluate a competitive exclusion product. Specifically, they wanted to know how it performed in a layer house within their production system. So to look at this, we sampled 2 farms side by side. Here you can see them labeled as Layer Farm A, where the product was used, and then Layer Farm B, which served as our control. Farm A had previously had a Mycoplasma gallisepticum outbreak, and the operation wanted to know really 2 things. Could we still detect NG in the barn? And could we detect the use of this new competitive exclusion product itself? So both of these flocks that we looked at were a bit older, and we sampled them each a couple of times. Farm B was a little bit of a different situation, which acted as the control. That flock had just been molted and had dealt with egg drop syndrome and spotty liver disease previously. So the questions with those samples were whether those duck adenovirus and Campylobacter hepaticus were still present in the environment. And that farm did not have the product application, so that was our control. So the nice thing about Barnwell Bio is that we can really answer a lot of questions with just one sample. But today, for this specific case, I'm going to focus on the intervention piece. So we were able to give them all of their answers, but today I want to specifically share with you what we found regarding the competitive exclusion product. So here are the data. This slide shows what the overall microbiome community looked like on both farms across the 2 sampling time points. So I'm going to break this down by starting with Farm A. Farm A sample 1 is the pre-product application sample. In general, you can see it's a pretty normal microbiome with what we would expect with genera like Staphylococcus, Corynebacterium, and Brachybacterium. We generally see those in our microbiome in the poultry house. We did see a higher amount of Corynebacterium in the first sample on Farm A than we normally do, and after chatting with the producer there, it was likely due to a water leak that had occurred in the barn a week or so before sampling. However, in the post-product application sample for Farm A, you can see that there's a significant drop in all the bacteria in general. We also pick up some new genera like Curavirus and Scape virus. These are both bacteriophages, which likely, based on our information, were introduced from the competitive exclusion product itself. Now, if we look at Farm B, which was our control farm, we once again see similar bacteria making up the microbiome. That includes our Staphylococcus and our Brevibacterium. However, what you will notice here is that from sample 1 and 2, the control stays pretty similar. The amount of colors that we're seeing that make up those stacked bar charts is pretty similar from sample 1 and sample 2. We also look at a few different metrics to better understand the microbiome. I'm not showing that here, but one of those metrics is called ecosystem variability, which looks at how different is sample 1 from sample 2. In this case, we saw that on Farm B, the control samples, ecosystem variability was really low. Those 2 samples were very similar. The microbiome stayed very much the same. These 2 samples looked a lot alike. And then on Farm A, where we saw the product being applied, we had really high ecosystem variability, meaning that the microbiome in the barn had changed drastically following the product application. Now, here's just another way to look at this data and explain the results. You can see we have a control samples for Farm B, and then the pre and post product application for Farm A. And for the first Farm A sample, you can see that it looks pretty similar to those 2 control samples. However, in the post-product sample, we see the introduction of those bacteriophages and then a dramatic reduction in the pre-existing microbial community that was there on the first sample. So our recommendations to the Mid-States Animal Health team was to potentially use a probiotic after they use the competitive exclusion product to help establish a healthy microbiome. After that consultation, the team decided to do some more testing to look at different timing and application options for this CE product and a probiotic that they were already using on the farm. So there's definitely more to come in this with this story in the future, and we're looking forward to sharing it. And with that, I am going to hand it over to our panel folks that I'm very excited to hear from. So I'll start by handing it over to Dr. Walker from Vital Farms. Thank you, Dr. Walker.
Thank you so much. Hopefully everyone can hear me. I suspect you'll yell out or chat if you don't. This is from the field. I'm in the field, so I'm at one of our company-owned research farms right now. So I apologize if you hear any egg packing activity in the background, but that's what we do. So, and that's exactly where this case came from. So the hunt for EDS 76, as they call it. First, just a little background on the virus, the agent itself we were after. Duck adenovirus 1 is the strain name. It's in the genus Adenovirus. So they're serologically distinct from the other 11 adenoviruses. They're kind of different. It's a non-enveloped double-stranded DNA virus. So it's a hardy virus in the environment, easily transmitted. And back last summer, about a year ago, Dr. Jason and I were studying hard for a board exam. And if you read the book on this one, the book says that it has not been detected in the US yet. Well, that is outdated information. It reemerged in the US in broiler breeder flocks and commercial layer flocks in about 2018 after circulating in wild waterfowl. So it's here, and this is a real world case of it. So next point, please. So here's an example of what this looks like in clinical presentation, and it could be described as an acute drop in egg production with really no other clinical signs other than what eggs are produced are usually pale, and they either have a really thin shell or they're even shellless. Some call them jelly eggs. And this was a picture of the case farm in question I took of their egg belt back when we worked this case up. But yeah, acute drop in egg production followed by unusable eggs. Here at Vital Farms, I started in January. Our first case of EDS was diagnosed in October of 2024. Some point in 2025, before my time, I can't take credit for it, but a mass vaccination campaign was pursued. And this year so far, knock on wood, only been one case, and that's the case we will discuss. So this all started, again, we use Barnwell on our company-owned research farms, and I would see alerts come across for like Marek's disease, serotype 2, and I thought, that's when I emailed Natalie, and I was like, wait, you can do DNA viruses? That's really cool. I have one for you, and that would be egg drop syndrome. So we had a farm, the Layer House 1, that's our case, that had been diagnosed and confirmed by the state it was in for egg drop syndrome. What I wanted to know, where this all started, was can I detect this in the litter by taking a litter sample and sending to Barnwell Bio? Of course, we had a control house. Strategically selected this one as a house that had been previously infected with EDS, the last flock, and had been cleaned out, and they had just placed. So it was a brand new flock placement in the lay barn. I stopped at that one first, obviously, and then went down the road to the case house. So that's kind of how these two houses are related, but Layer House 2 is our control case. Different age, previously infected, but not currently infected, and reporting no clinical signs. The case house, however, had already, we had confirmed EDS on PCR. Egg production had acutely dropped with obvious shell quality issues. And while I was there, taking the sample, working with the farmer, I noticed him kind of rubbing his arms a little bit. And I looked, and he had some mites crawling on him. And I was like, oh boy, we're getting into it now. So not only had he just been diagnosed with EDS, but there were also mites on the farm. Not while I was there, just a little added bonus. So my question was again, can we detect EDS in the environment? And what else can we find? Mites being pretty high on that suspected list of agents after visiting the farm to collect the sample. So when we got the results back, um, we did detect EDS. So this farm was designated as a high alert for Atadenovirus A. So that's the genus Atadenovirus, it's where egg drop syndrome is. We also noticed a high alert for C. hepaticus. So in the layer world, especially pasture-raised layers, that means spotty liver disease. So that was something I was able to communicate to that farmer, that perhaps we should be on alert for that and get ready to address that too. They were also able to detect mites. So that's that big bar on the far right, the northern fowl mite. And that also just added another layer of interest in this case for me. So there were three of my top pathogens, agents of concern as a layer veterinarian that I was able to detect with a single boot sock sample and confirm EDS and get some bonuses on top of that. Um, Obviously, it goes without saying, but we didn't detect any of those agents at the case, the control house. So they were absent. So with this information, knock on wood, we haven't had another case of EDS since this one, but if it were to rear its head again, one of the ways we could use this is perhaps for a surveillance tool to look around other farms in the area, and try to get a better idea of how this disease is spreading and how to prevent further spread with information gleaned from this from a simple boot swab sample. So with that, should wrap me up, and I'll pass it on to my colleague, Dr. Sousa.
Great. Thank you, Jason. There's Grayson, and we'll hand it off to Jason.
All right, thank you. So this is a case that is really something unique that you don't really get to see very often. So Amick Farms, were a broiler company based in South Carolina. We have locations in South Carolina, Mississippi, as well as the Delmarva region. And I cover our South Carolina and Mississippi locations. And this is a series of cases that was happening in South Carolina this winter. The context was this winter we dealt with a lot of infectious bronchitis, some laryngotracheitis, and mixed in was avian metapneumovirus. Every now and again, some Newcastle disease popped up. And so that really is the context of what I was going into when I visited this farm. I've been telling a lot of our team this year, it's called respiratory complex, not respiratory simple, because these situations, all these respiratory viruses, get real complex very quickly. And so what happened, this farm was about 35 days when I first visited it. And I identified primarily air saculitis and respiratory infections. That was the main concern. In fact, I'd been called out not because the mortality was crazy high, but because they said this grower is really picky. Before I tell him I think he has some of what we're seeing on other farms, I just want to have you come look. That way the vet has told me. And so I went out there. I said, okay, yeah, I'll take a look. And in the mortality, coincidentally, I identified several birds with vegetative valvular endocarditis, a really unique lesion. You don't see it very often in poultry, and was something the minute I saw it, I said, we need to culture this. We need to figure out what this is, why it's here, and why it's in multiple birds. And so this farm, at 35 days, tested positive for Streptococcus galliticus, as well as Streptococcus pleuranimelium from the heart valve, bone marrow, and liver. Really interesting, as for the most part, Streptococcus galliticus has been identified as more of a turkey pathogen. So I said, well, why are these birds getting Streptococcus endocarditis? In fact, to the point that I said, well, maybe this was just a coincidence. Let me come back. And so I came back multiple times to this farm and could consistently find about 10 to 20% of the mortality in this house that had endocarditis. And so these samples, I said, well, maybe there's just a lot of streptococcus in the environment. It's just overwhelming. They've already got some other challenges, and that streptococcus takes advantage of what's going on because there's so much of it. And so you can see that at processing age, I actually came in, birds were being in the process of being caught to take to the processing plant. And I went in our control house, which was basically a house that I hadn't seen the endocarditis in on the same farm, and actually had already been loaded out. So it was completely empty as I was walking through it. And then house one, which was the house I'd found the most in, and they were in the process of being loaded out while I was walking through and taking these boot sock samples. So again, the mortality had leveled out, was not crazy, but I detected infectious bronchitis variant, some avian metapneumovirus. We were vaccinating with a live laryngotracheitis vaccine. We were not vaccinating with a live Newcastle, but I did find Newcastle as well. And so just a lot going on in these houses. And then, not too long after that, I found another farm. We can stay on the same slide. Yeah, another farm, that's Farm B, that also had endocarditis, and I also recovered Streptococcus galliticus from it. We had detected avian metapneumovirus. They'd been vaccinated for laryngotracheitis and this bronchitis variant. But it led me to question, why am I having multiple farms with this Streptococcus coming out of it? And so that was where the boot sock samples came in. And I think now we can move forward. And this is what those results looked like. And really what was interesting is there was no clear difference in levels of streptococcus in the house that had endocarditis compared to the control. You can see there were some flags for some streptococcus oralis and hyointestinalis, but the strep that was actually found in the heart was Streptococcus galliticus and Streptococcus pleuranimelium, which were really not significantly different across these farms. And so my conclusion here was it's probably not that there's excessive streptococcus in the environment, but more so that the conditions that these birds were suffering from were predisposing them in some way, shape, or form to endocarditis in the first place. Going back to Virchow's triad and all the conditions that lead to abnormal blood flow and blood clots and give the opportunity for endocarditis to form. And in fact, since this case occurred, I've had two more farms that I've found endocarditis on, where one of those cases was actually Enterococcus saccharum rather than Streptococcus, all again supporting the idea that there's a common predisposing factor, but the abundance of the bacteria itself was not what was contributing to the infections. And so this was, again, looking at some of the abundance of genera, and Streptococcus overall relatively low. There were some questions about Lactobacillus crispidus, and if that was being driven by our probiotic, because we do have a probiotic in the feed fairly regularly. To my understanding, crispidus is actually not one of the strains in our probiotic, but perhaps that's driving, our probiotic is driving some of those changes. And then there were some questions about Cellomonas as like a marker of gut dysbiosis. And if we had treated these birds with antibiotics at any point in time, which were actually antibiotic free in South Carolina in our broilers. And so made it really simple to say these birds haven't received antibiotics ever. But perhaps it's not unreasonable to say that there could be some gut disturbances, especially given the fact that they haven't received antibiotics, namely ionophores.
Well, thank you both so much for sharing those cases. I think they're both really interesting, and it's been great to work with you both as we kind of worked through all the data related to those. With that, we will happily open up any questions that folks have. Feel free to put them in the Q&A, and we'll go over there and take a look and get those answered. Okay, so the first question we have is talk us through the sampling process from your perspective. So either Jason or Grayson, whoever wants to take this one, how much time did it take and were there did you versus other diagnostics or testing methods that you've done on those farms?
I can lead us off. Sorry, there's a four-wheeler outside. Okay. Yeah, so I would say start to finish, it would be like a typical farm visit for me. Go in, walk the house each side, except this time I just popped a squat on the slats and had my kit and using the gloves that were in the kit, slipped it over the boot covers I already had on as clean as possible, and then just did what I would normally do, which is walk the house with the farmer, and learn more, and then stop before I walked out, take it off, put it in a sample bag that already had sample buffer in it, and then put it on the ice pack it came with and the pre-labeled shipping label and take it to FedEx. So all that said and done, I think, 15, 20 minutes for the actual sampling process itself for me anyway. And that's not too different than what we would do for like SE swabs in the layer world. So it was relatively simple.
Jason, anything to add in the broiler world?
I'd say honestly, the amount of time it took me to carry out 20, processing age dead broilers and cut them open took 10 times as long as just slipping on the boot covers, walking down the house, and putting them back in their container. We have regular pickups from FedEx, so I just kind of put them in the fridge till I'm ready, and then package it up, put it where all of our other packages go, and it's pretty simple.
Great, thank you both. The next question is, did anything surprise you about the data? Who wants to start?
I can go quick. I was surprised we found EDS a little bit from litter, but not really when you think about it, I guess. But for diagnostic testing that we usually send whole eggs, jelly eggs, or swabs of the oviduct even, I would imagine, if you couldn't find eggs to test. But finding that in the litter was pretty cool. Of course, maybe not all too surprising because it's a pretty hardy non-enveloped DNA virus, so it hangs out in the environment. Wherever birds are, it probably is. I was really surprised we were able to drill down to the species of mites that were on that farm. So one of the questions I usually have is, are we dealing with northern fowl mites or red mites? Usually have to send those off for identification, but we were able to detect those. And then again, Campylobacter hepaticus was another bonus for me. Just trying to get ahead of spotty liver disease was pretty cool. So it was all surprising for me in a good way.
That's what we like to hear. Jason, what about you? Anything surprising in your data?
I mean, I walked into it with my hypothesis that like these farms were going to be loaded with streptococcus. Like that's why we're getting it. We just have more streptococcus here. And so it would, in hindsight, it all kind of made sense. But at the time, I'm like, oh, okay, no, well, there goes that theory. So I really had to like pivot, but it was helpful in actually like pointing my diagnostic investigation because I really want to get at the pathogenesis of what's going on. And so I was very quickly able to say, like, I don't think this is coming from the environment. but maybe it's what else is common between all these flocks. So it was helpful to have it as a diagnostic puzzle piece that it didn't give me all the information, but certainly when combined with my cultures and PCRs and clinically what I'm seeing in these birds just really helped me move forward with that investigation.
Yeah, that's good to hear. Yeah, we can help rule out and we can help rule in.
And not spend time like chasing streptococcus in the environment either. Like, oh, we need to clean out, do it. I was able to say like, okay, well, it's not the litter that's coming from.
Right. The next question we have, I can answer this one, is can Barnwell bioanalysis quantify specific virulence genes? For example, in E. coli. And yes, we can do that. So we're able to look at both strains of avian pathogenic E. coli and then look at the top 5 virulence genes and associate a risk of it being APEC based on the number of virulence genes we're seeing. And it looks like there may be one more question. Let's see here. Yeah, the next question is how are reportable diseases handled if detected? So there's a couple answers for that. One that is of concern for a lot of our layers is salmonella. So right now it's really easy to add or remove things from the dashboard. So I'm able to easily just not show salmonella. We can store that data and retrospectively analyze it. So if you have regulatory concerns around salmonella, we can just not look at it. Other pathogens, because they are environmental samples, I tend to defer to the veterinarian that I'm working with who's on farm and has that clinical experience. So I will say, hey, we've detected this, this, and this. I'll leave it up to you and your clinical judgment to decide if that is something you're seeing in the birds and it needs to be reported. Let's see if there's any other questions. Okay, next question. How often, let's see. How often do you feel you'll want to use the swab to stay ahead of potential issues? Grayson, do you want to take that one since you guys are doing some proactive surveillance on your farms?
Yeah. So we do weekly swabs here at our research company owned barns, and every week we kind of get a report of the pathogen risk profile. Um, that's a perfect world, right? So we have the ability to do that here. I would love to do it more out in farms within our network, but it would almost fall on the owner of that farm to decide how frequently they want to do it. And again, if it would be worth it for them, of course I can, recommend it, but I would say weekly or at least once a month I would take, or even quarterly. I would take whatever they would be willing to do. But weekly is pretty nice from a research standpoint, and in general, if you have the capacity to do it.
I agree. I think to allow for proactive surveillance, right, so that you can make decisions preemptively based on what we're seeing weekly is really great. Less frequently could be feasible depending on the bacteria or pathogen of concern. So if you have a sampling idea in mind, feel free to reach out and we're happy to chat through what that looks like. As I said, we're really flexible to work with folks designing studies that fit the questions that they have and really help them better understand how to take this data and make it applicable to what they need to know to support the health of the birds on the operation. Let's see if there's any other questions. Okay. So we do have a question about how cost effective is testing. And I can take this one as well. So it really just depends on how you want to look at it. When you factor in the number of animals that we're sampling, right? Because it's an aggregate sample of the barn and the number of pathogens that we cover, it's extremely cost effective. We do price each study or project based on the scope, the number of samples, and then it's a bit of a separate pricing scheme if you want to do that proactive surveillance where it's weekly testing. So feel free to reach out to us and we'll chat more about what that pricing looks for your specific project. Next question is, do we do any international testing? We currently do some testing in Canada. So they collect samples. We have to do some heat treatment to mitigate HPAI concerns, and then those samples get shipped to the US for testing. If you are an international company or organization and you're interested in doing some testing, feel free to reach out and we're happy to work through the necessary steps to support you. Okay. Any other questions? It looks like we have a couple more minutes. Okay, well, it looks like one more question, and I'll have both of you guys answer this. So let's start with Jason, and then we'll go Grayson. What other future cases can you imagine for these sampling kits on your operations that you work with?
So I think this is I like this type of diagnostic approach, especially when considering like feed additives and like the nutritional area, because that's an area I've always felt weaker in, but also is just a little bit more ambiguous. There's less answers on is it working, is it not, and so trying to make a case for different probiotics, I feel like this is something I could see being useful because you can visualize shifts a little bit better. And then exactly how I've already used it, where I've said, "Ooh, this is a weird problem, involves some bacteria. I want to know, you know, is there something going on in the environment that can tell us more about it?" We've also talked about using this for like spike males. That we have so many farms that I'm not a big fan of collecting data that I don't know what I'm going to do with. And so doing this on every single farm across the complex would be more data than I'd ever have time to actually look at and meaningfully evaluate. But for some of our high risk farms, like our stud farm with all the spike males that are going to get moved to basically all of our breeder farms, that's an area where it may actually help identify issues before they happen. And so that's something that we're looking at potentially implementing as well.
And Jason, I think those are all great examples. I will say we're here to help support with all of the data that you do receive. So I love looking at numbers and digging through, everything that comes my way. So feel free, if you do ever end up making it go larger as a surveillance program, we're here to support you through that. Grayson?
Yeah, so literally 20 feet from me, I believe we're doing a study right now testing a probiotic, so very similar to what Jason just said. Again, it's looking mostly at the composition, and I'm working with the manufacturer of that probiotic because we know what's in the probiotic, and can we see that cycle through the litter, would be awesome. So if I could stay in bacteria all day long, I would because that's where I'm comfortable, but probably my next step is to branch out and do some parasitology work with it. And for me, that translates to coccycycling and pullets. So looking at that and different vaccination programs and strategies and trying to monitor that.
Well, thank you both. And yes, those are all great projects that we either have in the works or I'm looking forward to working with you both. It's been such a great experience over the last few months getting to know you guys and working on these really interesting targeted investigations. So with that, we will all be at AAAP here next week. So feel free to find us if you have any additional questions regarding these cases or what Barnwell Bio has to do, or if you want to talk to Dr. Walker or Dr. Sousa about how they've used Barnwell Bio and what their experience looks like without me being there, you are more than welcome to do that as well. So with that, thank you guys for joining us. Thank you, Grayson and Jason, for taking the time today to share these cases and talk about this really unique perspective that you have of working on these different operations. So if you have any specific questions for us here at Barnwell Bio, feel free to email us at hello@barnwellbio.com. Our website is also there too. If you registered for the webinar, you will get a link of the recording afterwards, so you can always reach out with any additional questions you may have. So with that, thank you all, and we will hopefully see you soon.